Welcome to this quick tutorial on Jamovi, a free and open source statistical software built on top of R that will make data analysis incredibly quick and easy. First things first, let's get it installed. Head over to jamovi.org. You'll see two options, Jamovi Cloud and Jamovi Desktop. I recommend choosing Jamovi Desktop. Depending on whether you have a Mac or a PC, you'll see options for download. For Mac, you'll see option for Apple Silicon and Intel-based Mac. Choose the option that's right for you and it'll download the install file. Just follow the install instructions and you will have Jamovi installed. Now that we have Jamovi open, let's bring in some data. Click on the three horizontal lines on the top left corner. Select Open, hit Browse, and navigate to where your data file is stored. You should have downloaded the week1_gss.dta file from Canvas by now. Jamovi handles CSV, Excel, SPSS, SAS, and Stata files seamlessly. This is a DTA file, which is Stata's native file format, but we'll use it for Jamovi. Select the file, click Open, and just like that, your data fills the spreadsheet grid on the left, while you have a blank output window on the right. Before we go in, let's talk about the data we'll be using. This is a trimmed down version of the General Social Survey, or GSS, which is a long-running survey that asks a random sample of Americans about their opinions, behaviors, and demographics. Instead of working with the full survey, which has hundreds of variables, I have cut it down to just 9. Age, sex, and race, which are basic demographics, marital status, child's, which tells us how many children a respondent has, CRAS, which captures opinions on weed legalization, ABNE, opinion on abortion access, TV hours, how many hours of TV someone watches per day, and wet years, which tells us about a respondent's military service length. I picked this smaller set so you can get comfortable with the mechanics of data analysis without getting lost in a sea of columns. Once you are comfortable here, the same skills apply directly to the full GSS or any other dataset you'll work with. To see what's going on in the dataset, we need to look at the variables. Head over to the Variables tab. On the left side, you can see the name of the variables that I had just listed, along with a useful description. Several datasets come with descriptions for variables already built in. However, in many cases, descriptions are not available. In such cases, you can write your own descriptions. Now, if you double-click on a variable, it shows you some more useful information on the top. It shows you what kind of a variable Jamovi thinks it is, like nominal, ordinal, interval, and what kind of data it is stored as, decimal, integer, character, etc. Jamovi also uses icons to represent levels of measurement, a text icon or Venn diagram for nominal groups, a stepped bar chart for ordinal rank data, which we don't have here, and a ruler for continuous numeric data. Jamovi usually guesses these correctly, but you can override them here. There is a levels box as well here. If you click on a categorical variable like race, Jamovi automatically lists out all the unique groups or levels present in that column, making an interpretation of data easier. Let's get into some actual statistics. To find our measures of central tendency and dispersion, go to the Analysis tab, click Exploration, and select Descriptives. A new Options panel opens up. Drag your numeric variable, let's say age, over into the Variables box. Look at the right side of your screen. Jamovi has already calculated the mean, median, minimum, and maximum for you. To get more detailed statistics, click on the Statistics drop-down menu below. Here, we can check the box for Mode to complete our measures of central tendency. The table on the right will update instantly. If you're working with categorical data, looking at a mean doesn't make much sense. Instead, we want to see how often each category shows up. In that same descriptives panel, simply check the box next to frequency tables. If you pass a nominal or ordinal variable over into analysis, like race, Jamovi builds a frequency table showing the counts and percentages for each level. Finally, let's look at how to create a dummy variable. Go to the Data tab and click Transform. This creates a new column. Let's name it Has Children. Click on the drop-down menu next to Source Variable and select Child's, which is the variable we are building our dummy variable from. Click on the drop-down menu next to Using Transform and select Create New Transform. you can select a name or keep it as transform1. Now, click on the add recode condition where it says if source, enter the greater than sign and then enter 0. Then next to use, enter 1. Finally, next to else use, enter 0. If you're wondering what we just did, let's break it down. The variable child stores the number of children each respondent has. By entering greater than 0 in the if source box, we are telling Jamovi to look for everyone with 1 or more children. Next to use, we entered 1, meaning those respondents will be coded as 1. Finally, else use 0 tells Jamovi that everyone else, those with no children, should receive a 0. In other words, we have turned the original variable into a simple yes or no indicator for whether someone has children. You can also change the measure type to be nominal in the drop-down menu to ensure that Jamovi can recognize the new variable as nominal instead of automatically assigning it a wrong category. Press enter when you are done. Alright, now that we have created a new dummy variable, let's see if it was formed right. Click on the downward pointing arrow, then click on data. We can see that the new variable has already been formed. If you look at the variable child's and compare it to the new variable, you'll see that in every observation where child's value is 1 or more, has children is 1, otherwise it is 0. That is exactly what we had specified. Now, let us create another dummy variable based on the variable wet years. Look at the data closely. Instead of saying exactly how many years the respondent served, it puts them in a category of none, less than 2 years, 2 to 4 years, or more than 4 years. However, the underlying data doesn't have those words and stores the data as 1, 2, 3, and 4, corresponding to the 4 categories just listed. To see which number corresponds to which category, we can check the levels for the wet years dataset. Go to the variables, double-click on wet years, and you can see the 4 levels. It is clear that if an observation is 1 for that variable, that respondent is not a veteran, while if it is anything else, it means that they are a veteran. This is all we need to know to create the dummy variable. We'll click on the transform again, and this time name the variable wet status. Source variable is wet years, and we'll create another transform. Click on add recode condition, and next to if source, enter ==1, then next to use, enter 0. Essentially, it means that if the underlying variable is 1, which is the numeric value for none category, then it codes the wet status as 0. Next to else use, enter 1. Change the measure type to nominal for good measure and add a description. There, your new variable is ready. You can go and check the data to see if it was created correctly. Last step, let's save our work so we don't lose any of this. Head back to that application menu in the top left corner and click Save As. Jamovi will save everything, including your data, any new variables you created, like has children and wet status, and all of your analysis into a single OMV file. This is Jamovi's native format. So if you or someone else reopens it later, all your output tables will still be there. Now, sometimes you'll want to get results out of Jamovi and into something like a Word document or a slide deck. For that, right-click on any results table or plot in the output window, and you'll see options like Copy or Export. Copy lets you paste the table directly into Word or PowerPoint with formatting. For most of your assignments, you would be copy and pasting only the relevant tables into your answer documents. Lastly, if you ever need the underlying data itself, for example, to bring has children into Excel or another program, go to the application menu, click Save As, and choose a format like CSV instead of OMV. That'll give you a plain data file with all of your new variables included, ready to use anywhere. Note here that this only saves the underlying data, which means variable descriptions and labels may get lost. Thank you so much for watching this video, and I hope that this will be helpful for your assignments.